Hello, my name is Arian, and I'm very happy to share my research findings with you today. Did you know that in recovery of bitumen from Alberta reservoirs, a lot of steam is injected in the formation? Hot steam injected warms the cold bitumen, making it easier for the fluid to be produced in this process. But what we know from the field samples and the observation and lab testings is that the produced fluid in this process is always in form of an emulsion, where water droplets are dispersed in a continuous oil phase. The emulsion is stabilized by the natural substances that are present in the reservoir and in the fluids. But why is this important? This is important because the characteristics of emulsions are very different from the single phase fluid, and the way emulsion flows is also very different. This could lead to change in production with emulsion compared to the single phase production. Also, there are considerations when it comes to downstream and processing of the produced crude. Basic sediment and water content and salt content, these are considerations that are very important when it comes to the production of the crude from the reservoir. So in this research, we tried to come up with a model emulsion which replicates the properties of the field emulsions in the reservoir. To do this, we use different technologies and different methods to determine the features of the emulsion. For example, we used optical microscopy, where emulsion samples were observed under a microscope and images were captured from the sample emulsions. The images were then processed using image processing software suites and programs to find and determine the size of the particles and droplets in the system. Also, we measured the forces between the phases of the emulsion system using different techniques. Moreover, we tracked the separation of phases with time. These are all very important aspects and features of emulsion that we wanted to monitor, and we wanted to make sure the model emulsions have the same properties as the field emulsion features. But that is not all. To better understand the physics, we used computer simulation to track the motion of molecules and the forces between molecules in the system, and to better understand how the emulsions are stabilized by some of specific substances that are present in the system. This was done by molecular dynamic simulation. The application of this research is very extensive. First of all, currently we are neglecting the emulsion flow in the lab testings. We can optimize the production, come up with new production strategies and methods, and optimize the production from the reservoir by implementing and injecting emulsion instead of single phase fluid injection. This leads to improved production, this leads to improving efficiency, and also new recovering methods can be introduced in this way and can get a lot of help from the findings that are provided in this research presented here. Thank you very much.